This is a lab problem from section 3.8. It says here that the half-life of cesium-137 is 30 years. So 30 years is our half-life. Suppose we have a 20 milligram sample. We want to find the mass after t years. So we basically want to find the function that's going to model this. In general, we know that y of t is going to be y of 0 times e to the kt. So y of 0 is the beginning sample, and it looks like we have 20 milligrams from the beginning. Since the half-life is 30 years, we know that when y of 30 is going to be half of 20, and so half of 20 is 10. And so now when we use this information that after 30 years our function is going to have 30 in for t, and we know that y of 30 is equal to 10. So when we solve for this, we're going to divide out by 20 to get e to the 30k by itself. So this is going to be 10 over 20, which is 1/2. And then so if we solve for that, we'll take e of both sides, not e, but we'll take the ln of both sides. We're going to have 30k is equal to ln of 1/2, and then we'll divide by 30. So that's going to be 1 over 30 times ln of 1/2. Oops, let's put the parentheses at the proper place. And so that's going to be our k. Now notice that their response here, their answer is negative ln2. It turns out that 1/2 is 2 to the negative first power, and you can imagine bringing that 2 down. So this is just a more concise way of writing our solution. Now remembering that this is true in this property with e to the ln, we have e, or 20, times e to the t over 30 times this is going to be equal to, so now let's imagine bringing this as a power of 2, and then maybe we should make sure that we write this out properly. So we have 20, times e raised to the, and then we have a t over 30. Actually that 30 is under the ln, but since we're multiplying and dividing, it kind of would work out the same way. So that's t over 30 times minus ln of 2. So according to their properties, we can rewrite this thing as equal to, let's take this as a power of 2 in here. Now this is going to be harder to read because it's getting power and power, and let's see if we can make it a little bit bigger. We can also take this negative sign out and put that as part of the power, so that comes up over here with the power. And then now we have e to the ln of this thing, and so the ln of this thing is just going to be that thing. And so we're going to have left here, whoops, what we're going to have left here is the 20 that's sitting out in front, and then the e and the ln would undo each other, and so we would just have times 2 raised to the negative 1 over t over 30. So let's see if we can put that in here. That's 20 times, and then we have 2 raised to, and this is our power, negative t over 30. Okay. So that is the function that describes the amount of mass that's left after time t. So now they want to know how much is left after 20 years. So we're essentially going to put 20 in for t. Let's see what they have here. After 20 years, we have the following. This is going to be 20 times 2 to the, this is going to be a negative 20 over 30, so that's negative 2/3. And then they want us to put that in our calculator, so let's take our calculator out. Let's give some space here. So we have 20 times 2 raised to the negative, oops, let's be careful with the negative. This is the negative sign that I want, negative, and then we have 2 divided by 3. Again, if your graphing calculator does not put you up here as an exponent and then you just see a caret, this caret symbol, then make sure you put parentheses around the negative 2/3 here. Otherwise, it might not come out right. So we want to round off to 2 decimal places. This is 12.599. Now, rounding out to 2 decimal places will make this a 10, so that makes this a 60. And I think that should work out for us. And then how long will it remain after, how long will it be until you only have 1 milligram left? So to find this, we must solve this equation where you have 1 milligram out of that function over here. And so it looks like we're going to solve for t, the t over here. So let's see what happens. So we want to solve for this thing when this expression over here is equal to 1. So what do? Well, first we'll divide by 20. And then we'll take the ln of both sides. We actually, the best deal to do is to take the log base 2. Let's say base 2 of this value. So log base 2 of that value, and then that would give us this expression over here. I probably should have been copying this and doing this in steps, but and then to solve for t, you just multiply both sides by negative 30. So let's do a minus 30, and then that would just make this a t, and then that's the expression that we're looking for, minus 30 log base 2 of 1 over 20. And then I suppose you can put that in your calculator to get the actual value. And to do that, since you don't have a log base 2 in your calculator, you should use the ln or log, and here they decide to use the ln. So we'll keep the 1 over 20 here, and then we just need to punch this into our calculator. So back with our calculators, we have a minus 30 times, and here we have a fraction, but since you're multiplying and dividing, it's going to be all the same. So the ln is this button over here, the ln of 1 over 20, 1 divided by 20. And then we're going to divide this whole thing by ln of 2. And then that should be it. So it looks like it's going to take 129 years, 129.65. Let's just round off that expression to 129.7 if we want to round off to 1 decimal place. And then that's it.